Hi, everyone. For those of you who don't know me, my name's Harry. I'm a distributed systems engineer at Wallet Connect, as well as working on other open source stuff in my spare time, both Web3 related and not. You might have seen me around Superbase maybe. And today I'm here to talk to you about the distributed webhook solution that we've started working on at Wallet Connect and are continuing to work on now. As a quick intro for people who don't know what Wallet Connect is, we're the QR code you see when you need to connect your mobile wallet to your desktop dApp. We're in major dApps like OpenSea, PancakeSwap, and others like that, as well as integrated by over 150 wallets. Now we'll get on to what webhooks are. I know some of you here may already know what they are, but so that everybody's on the same page, let's imagine we have two servers, or just two computers in general, and one needs to send an asynchronous message to the other, where it has no way of knowing if the other's on, and it has no way of knowing the state of the other. So it can send a payload like this. For example, this is for a new address being registered on one, and it needs to send it to the other. It normally sends it over HTTP, so a post request from my server to yours, and it's something like /hook, or some people name them a bit smarter, so /wallet connect or whatever you need. But there are some inherent problems with webhooks. First of all, I have my laptop here. I find out what your server is, and then I start sending webhooks to it. So I send this new address one over and over with random addresses, and your server's then flooded. You then have the inherent security problem of what can this server trust? Before we get on to how we can secure these, why am I even talking about webhooks? At Wallet Connect, we use them currently for push notifications with our newish push API, where your desktop dApps, so OpenSea and others like that, will be able to send notifications to your mobile wallet. For example, you have a new offer, or you need more liquidity, or something like that in OpenSea. Secondly, webhooks have less load than WebSockets. Traditional Wallet Connect uses WebSockets between each client, so your wallet has a webhook. No, your wallet has a WebSocket to the relay in V2, and so does the dApp, which is two WebSockets for one connection. So there's less load involved when we can just send them to servers, and they can be managed individually. And finally, there's more opportunities with webhooks. We no longer have the requirement for NIC-based limits with WebSockets. There's no required long-living TCP connections, and there's more security opportunities. We obviously don't plan to remove the WebSocket feature at any point soon, but we are obviously building this out with security in mind as options for people in the future. So how can we make this secure? Internally, we had a few options, so I'll go over three of them. There were obviously so many more that we would be here for hours if I went over them all, and the meetings where we brainstormed them all were probably not the most interesting. But the first and probably worst option was we just left it alone. We left no security on it, and we just hoped that nobody abused it. Obviously, with no security, we would lose trust. If people start sending you push notifications pretending to be OpenSea, it looks bad on us, it looks bad on OpenSea, and of course, worst of all, it looks bad on the wallet. So the first thing we looked at was signatures with ED25519, and there's actually two implementations we explored. The first one here is where the relay just has one public key. Each relay has a public key, as shown there, and we get a link between both servers, where my server or yours would request the relay's public key, store it somewhere, and then each time something came in, a signature would be sent with it so that you could verify that the payload you received was valid. Of course, there are still some flaws with this, so we iterated on this for a second time, hoping that we could make it a little bit better. So here's our second, and of course the chosen implementation. So you might ask, what was wrong with the first one? Well, there are three main issues. First of all, with decentralization as a constant goal at Wallet Connect, that solution doesn't work. Imagine we now have 6 providers. We have to share the private key amongst them all, and that completely defeats the point of the security then. We might as well have just kept no security at all. And if we had no security, we go back to the old point of no trust. Secondly, it's a single point of failure then. There is only one node, well, one private key that can sign everything. If I was to compromise it, you were to compromise it, or anybody else was to even accidentally compromise it, the entire security system is then broken. And finally, as a focus on single node support. Even though in theory there might be multiple nodes inside of the current V2 network, they all act like one. So there's a strong focus on that, which goes back to point one of no decentralization support. So what did we actually change? First of all, the relay would now look after, in theory, multiple public keys. They could be the same, but the spec now supports multiple, and each webhook has its own public key. So your webhook would have a separate one to mine, and then each time you send the relay signs something, it signs it with the specific one to that webhook, therefore defeating the first point of decentralization not working, because each relay can look after its own public keys now on a per webhook basis. So you might ask, you want to integrate a service with webhooks? What responsibilities do you have? First of all, you need to store the key the relay gives you. If you were to at any point lose it, you would then have to go back to your first option of no security. Secondly, you need to validate incoming requests. Of course, this is optional, but the security is there for a reason. If you're not using it, you're just as insecure as us not sending it. Third and finally, you need to decode and parse the messages we send you. We're sending now the traditional WebSocket messages you would get. They're now sent, but now over webhooks instead. So everything you would get over a WebSocket, you get over a webhook. We keep the same end-to-end encryption as well as the signatures, and the only person who can decrypt the message would be the wallet at the end. Of course, we strive to constantly improve. If you see anything glaringly wrong with it now, you can speak to me here over ETC. And of course, as always, any security reports, we welcome at security@walletconnect.com. Thank you so much for listening. And if there's any questions, I'm happy to take them now or around the conference.
Thank you. I was waiting. So I was waiting for the third slide where you build a distributed system to distribute those keys. Is there any heading? Are you planning on doing that?
As in the future decentralization of Wallet Connect? Or
No, as in a system to manage those keys and out.
So the keys are actually managed within the relay. We're working through implementations at the moment, and it's quite an ongoing system. We had a few implementations that we've then scrapped, but the general consensus is that each client ID has its own public key, or each webhook ID, which is like a derivative of client ID as well as a few things, has its own public key, which is then returned to the client, and then the client can send that on to the service that it registers with. But it's ongoing, and we hope to publish full specs soon. But there's the initial drafts are already up.
Where's that?
It should be at docs.walletconnect.com. I can get a link for you afterwards.
Good. Thank you.
Any other? Okay, well, thank you very much for having me, and I hope you enjoyed the talk. Of course, any other questions, please feel free to ask them here, and I'll be around the conference for the rest of the week.